Hey guys, we're continuing with part 13 of the Regents Review series in this video. So it says, base your answers to question 13 through 15 on the diagram below and on your knowledge of Earth science. The diagram represents a side view of the Earth. The North Pole and some latitudes are labeled. The dashed lines represent the Earth's axis. And you can see the Earth's axis is tilted towards the sun. Identify the season that is just beginning in the northern hemisphere when Earth is in this position. So your answer should be summer because the northern hemisphere is tilted towards the sun, and that's when we have summer. When it's the northern hemisphere is tilted away, we have winter. And you're looking at the axis. You can see that the axis is tilted towards the sun, the dotted line. So you have summer. If the axis was tilted away, it would be winter for the northern hemisphere. You can also find this in your Regents Review packet, page 17. On around June 21st, we have northern hemisphere summer, and the Earth, the northern hemisphere or the North Pole, is tilted towards the sun. This is our axis. Number 14, state the number of hours of daylight that would be experienced at the equator 3 months after the date represented by this diagram. So we already established that this is around June 21st. 3 months after June 21st should be September 21st. That's the first day of fall. So it should be 12 hours, your answer, because if you go on your Regents Review packet, page 17, for the equinoxes, the first day of fall and first day of spring, around March 21st and around September 21st, you have 12 hours of day and 12 hours of night and equal day. That's why we call it equinoxes in almost all parts of the world, pretty much all parts of the world. Number 15, state the general relationship between latitude and the duration of insolation on this day from the equator to 60° north. The answer, your acceptable responses but are not limited to, the greater the latitude, the greater the duration of insolation, or you can say a direct relationship. So what this is saying is, as we're going from the equator to a higher latitude, from equator to 60° north, we're actually having a higher duration of insolation. Duration meaning timing, how long it's going for, and insolation meaning the sunlight coming in, reaching the Earth's surface. So the higher you are going up in latitude from equator to 60° north, when the Earth is tilted towards the sun, you're actually getting more sunlight. That's what it's asking. Longer days, longer amounts of sunlight. And you can see as the Earth is spinning in this position, um, kind of like this. If you were someone in 60° north latitude and you were spinning around this area, you would be spending most of your time in the light and a little bit of time in the darker area, the shaded area in darkness. And then 30° north, you would spend a little less time in the light and then a little longer in the darkness. And in the equator, you would spend half of the time in the light and half of the time in the darkness. That's why as you're going more from equator to 60° north, that you have a higher duration of insolation as your latitude is increasing. That's it.